Hi there, welcome to another work in progress on Dominium. I just thought I'd do a quick video showing one of the techniques we're using for generating bounding volumes to use within the game itself. These are going to be used for collision detection, to do broad phase, weapons, firearm models and so on. But also my intention is to use it for a rather neat shield effect, which you might understand when you actually see the final result. We're using a technique called quick hull, which basically just takes an arbitrary point cloud, like you can see here, all these randomly placed dots, and then generates the smallest convex hull that will encapsulate all of these points. It's an interesting algorithm, so I just thought I'd show it off, going step by step, just to show how it actually builds out, because it's quite interesting to see. So here we've got random sphere generated by a cloud of points. As you can see, they're just all over the place. They're inside the sphere's outer edge and so forth. And the idea is you want to try and wrap it up basically in some geometry. So we start off by selecting any arbitrary triangle, to be honest, but we just done a quick algorithm to pick the largest triangle from 3 points within the cloud of points, as it were. And then all we do is we find a point that is the furthest away from one face of this triangle. So as you can see, that orange dot there is pretty much the furthest one available. That's at an almost perpendicular angle to the triangle's normal itself. So then we do is we form 3 more triangles from the edges of our parent triangle. Okay, you can see that there, and then we just basically close them in. And now we've got a kind of pyramid shape that takes up some volume and encapsulates other points within it as well. That's the important part. And all we do is we keep iterating all the triangles and doing exactly the same technique. So let's pick another one. There you go. So that triangle now, that point is the furthest away from it. It creates those. And you can see there's a line intersection going through the middle of the triangle. Basically, our chosen point here is finding all possible triangles. And then there's another algorithm that runs that finds the edges of any surface that it's facing. So it's actually, although the algorithm kind of looks from the triangle outwards, now we're looking from the point we found back towards the triangles to see which ones are actually facing it before we decide to close the volume off. You'll see this probably more clearly here. So that's just pick that point there. So now we've got multiple triangles there, but if you look at it from the point of view, as it were, you can see there's clearly a quad. So there's 4 edges. And we just close those off. And that's it, and we basically rinse repeat. Once it can't find any more triangles, we know the algorithm stopped, and that volume now is the smallest convex hull that encapsulates all of the points within that point cloud. Looks a bit like an asteroid. Could use it possibly for some procedural content there. Okay, so that's it working on a random point cloud. Let's see it working on one of Dom's spaceship models. Okie dokie, this is probably familiar, one of the Iranian Empire's naval cruisers. If we get rid of the model, so this is the point cloud, basically every vertex in that model. And you can see we've already selected a candidate triangle to start the search off. So there we go, there's our orange point there. And then we draw our lines. And off we go, basically. As you can see, it's quite quick. It's not quite real time, or the algorithm, the way it's implemented, it's designed to be ran offline. So whenever an artist updates a model, the toolchain will build the latest convex hull for it and save it, and the game engine just loads it up at runtime. So you can see we have the smallest volume to represent that ship. Okay, thank you for watching, and hopefully maybe next time we'll get to see the special effects I'm trying to implement for the shields, although that is a long way down the road. Cheers.